Hello again for this second video about this exercise with the motor, the inverter, and the interface using a PLC system, etc. As you remember, in the other video, I showed this connection, which is, well, fairly most common. But I said also that I wanted to explain or demonstrate that we can use an Arduino. So I just disconnected from power. Disconnected the PLC and installed an Arduino in parallel with the same digital interface to the home inverter. Since the Arduino, the version I have, has no analog output, I will not put the motor in the jog mode. But it's the same thing. I could install an add-on to the Arduino to have an analog output, and the application will be exactly the same. The connection between the PC and the Arduino is the USB port, the programming port of the Arduino, and the interface is equally the same. To make the interface, I used the 5 relays, S30 relays from, it's a common PCB relay. And I connected pin 13 and 12 of Arduino to pin 1 and 2 of the inverter. So these two pins command the direction of the motion, of the spinning. And then pins 8, 9, and 10 to the input pins of the inverter 5, 6, and 7 to define the user velocity. So again, if you look at my screen, let's finish this presentation and look at my laptop screen. You see my camera, the camera pointing to the system in front of me. You can see the motor here, the inverter, and the Arduino here, Arduino Uno here, the cable connected to my laptop, and here the circuit to interface the Arduino to the inverter. So let's open the Arduino programming environment. We can open a serial monitor there and do commands like this. For example, let's eye this thing to see the camera, to see the the motor moving. Let's do something like put the motor in stop mode. I don't know if it is in stop mode. Okay, we can, for example, do motor forward, which is a command to put the motor spinning in the forward direction, and then send, for example, motor velocity, let's say velocity 5, which means accessing the register, the memory register that has a predefined velocity. And you see motor is spinning. The frequency commanded here is, as previously, something around 35 Hertz. 35 Hertz. I can just, let's say, for example, do stop motor and ask him to spin motor in the backward direction, for example. It goes in the backward direction. For example, using another velocity, for example, motor velocity, oops, there, any missing? Motor velocity 7, which means 50 Hertz. And you see, the Arduino is playing a PLC. Now let's disconnect here and use serial interface as previously with other video showing the PLC interface. If you connect to the Arduino, so this is the serial interface. It's now in communication with the Arduino through the USB port. Now let's, for example, change the velocity, motor velocity, let's say to register 4, for example, send to Arduino. Motor decelerates. Let's say if you want to stop it, the velocity in register 1 is frequency 0. So if we send that command, it will stop. I can, for example, now change a motor to forward again, forward, send to the motor, and then send the frequency. For example, velocity, let's say full velocity, 50 Hertz. It's just sending the command, and it will start spinning in forward direction, and with the velocity of 50 Hertz, as you can see here in the inverter. And the 50 Hertz is on the screen. The circuit is over there. It's just a collection of relays to make the digital output of the Arduino to communicate, let's say, interface with the digital input of the inverter. They have different DC levels. Arduino is 0.5 volts. Inverter is 0.24 volts, and also the power is not compatible. So you need to make an interface. Let's stop the motor. Stop it. Motor stop. Motor stop. Oops. Sorry, it's not this command. It's invalid. So it's stop motor. Motor. The client informs us if the command was not issued correctly, and we can, to terminate this demonstration, disconnect from the Arduino. Hope you enjoy it. See you next time.